So today's objective is we will going to see the Turing machine programming techniques, and we are going to see the comparing two strings, how to compare the two strings, and afterwards we will see non-deterministic Turing machine. So we will see one by one. First one, we will see the Turing machine programming technique. So here, so what is the programming technique? Here, TM programming technique. Okay, programming technique. So what is the problem? Problem is, my problem is, how can we recognize the left end of the tape of a Turing machine? Like in the previous video, you have seen, if we have the tape, example, if I have a tape like this, okay, 1 2 3 4, okay, so 1 1 1 1 1, and here is this, and so on. So this is our tape, as we have discussed in the previous video. This is a tape, and here tape header, head. Okay, but here, so here which one is the leftmost? So here the problem is at the left end. Here at the left end, I don't know, this is a last, this is a left end element. I don't know about this. So how to recognize this? In previous techniques, whatever we have done in the previous videos, in push down automata, we use the stack. In the below of the stack, we use something like this, or empty, because we need to identify this is our last element in the, or last symbol in the stack. Okay, this is we have done in the PDA. In the same way, to identify which one is the left end in the Turing machine, so this is a problem, we need to solve this. So what is the problem? How can we, we'll do one thing, otherwise fine. Okay, so how can we recognize the left end of the tape, of the tape of a Turing machine, So this is a problem, how to recognize this is my last left end. Okay, this is my left end, how to recognize that? So that is, for that you need to use, like if you have a 1 1 1 1 in the tape example, okay, and the rest of the things are infinite. So here this is our tape. So the solution for this is, you need to use a dollar symbol at the left end, 1 1 1 1. So here, after adding the dollar, your file will be look this. Okay, dollar, sorry, so on, infinite. So whatever the left end, previously the tape was like this, okay, After adding the dollar, that means whenever you will get the dollar in the tape, then you can easily recognize or easily identify this is the last one at the left hand side, and you should not move at the left hand side, and you cannot move at the left left hand side. So you must move at the right hand side, as the tape Turing machine work on tape. Okay, either it one step it can move to the left side or at the right side. So if you are at the left in, so it is not possible to move at the left side. So how can you identify and how can you uh, recognize? With the help of dollar symbol you can easily recognize this. Okay, so here, okay, now what we are doing here, just we are doing, I'm just moving up, so I am doing here, just I am putting the special symbol. Okay, putting a special symbol, spatial symbol dollar, okay, on the left hand side, this on left hand or left end of the tape, to recognize the left end. Okay, and shift the input over one call, over one call to the right, over call to the right. Sorry, one cell to the right. Okay, so here, this one, what I am doing means, this is my the previous tape, and this is a problem how to identify at the left hand side, means left end, which number is my left end. If you want to recognize that, you need to add the special symbol, that is dollar, on the left end of the tape and shift the input over one cell to the right. So when you are in the left end, you should move to the right end, so you move to right side. Okay, this left and right, if you are not able to understand this, go and watch the previous video, then you can easily understand the concept of Turing machine. If you are directly watching this, then it is very difficult for you to remember. Okay, okay, so now we will move to next is, I created the new page. Now here I have one question, like build the technique Turing machine, build a Turing machine to recognize the language. What is the language? 0 power n, 1 power n, and 0 power n. So how can we read this? How can we read this? 0 power n, 1 power n, 0 power n. So 0 power n, okay, any number of zeros. How to read? Any number of zeros, followed by, okay, So we cannot write any here. We need to write n number of zeros followed by n number of ones, followed by n number of zeros. Okay, you can read n number of zeros followed by n number of ones followed by n number of zeros. So this is we can read this one in this way, or you can read equal number of zeros followed by equal number of ones followed by equal number of zeros. You can read that also. Okay, for this one, how we need to solve? As you know, already we solved the problem for this problem already we solved in the previous example. What was the problem? 0 power n, 1 power n. Okay, so what we have done, wherever the 0 is there, we replace with x, and wherever the 1 is there, we replace with y. So already we have done in the previous examples, but now we have a 3 numbers, n number of zeros followed by n number of ones followed by n number of zeros. So here what we need to do, we need to use the Turing machine as subroutine. Here then we need to use the TM as a subroutine. 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 So that means we need to divide it in the two parts, and we need to solve, and we need to combine. Okay, so what is the main advantage of Turing machine? As we have discussed in the introduction, that if in the Turing machine, if we have a big problem, okay, if any any big problem we have, so that we can divide it into subroutine and we can combine. Okay, so how to do that? Here we will go with the step 1. Okay, I will create new one. So here what we are doing in the step 1, first I will going to write here 0 power n, 1 power n, 0 power n. Okay, so here step 1, in the step 1 we have found 0 0 0. Example, I am taking 0 0 0 1 1 1 0 0 0. So this is my the input. Okay, input string, and this is valid because n number of zeros followed by n number of ones followed by n number of zeros. So this condition is satisfying here. So this is what we have done in the previous examples. 0 is replaced with x and y is replaced with 1. Okay, now keep as it is 0 as 0 right now, and this we have already solved is 0 power n, 1 power n. So this first is we have done. Okay, now the thing is we need to solve this two. We need to solve this two. Okay, and what it will be like here 0 power 1 and 1 power n. So here it will be, you can say y power n 0 power n. Okay, and for this you can write x power n y power n. This is a step 1. Now the step 2, in the step 2, build a similar Turing machine to recognize y power n 0 power n. So this x power n and y power n we already solved. So here now we need to build similar Turing machine to recognize y power n and 0 power n. So my step 2 is build the similar Turing machine to recognize y power n and 0 power n. I got x power n, y power n and y power n and 0 power n. So how to do this? Okay. So for this, the last step is step 3. Step 3 is build the final Turing machine. Okay, now build the final Turing machine, final Turing machine by combining. Now we have the two things, x power n, y power n, 0 power n. So Tm by combining these two small Tm, this two small Tm Turing machine together into one large Turing machine. Okay, so what is our first step? First step is, first already we have this equation. So in the step 1 we need to see 0 0 0 1 1 1 0 0 0. This is a valid string, and for x power n and y power n we have already finished in the previous video. So in the same way, after solving this, you need to solve the second. In the step 2 you need to solve the rest of the two what is that? Build similar TM to recognize y power n and 0 power n. So for this blue box, in the second step we are solving the blue box. In the first step we are solving the red box. And in the step 3, build the final Turing machine by combining these two, not this. This should be these two small TM together into one large Turing machine. Okay, so this is about the programming technique, Turing machine programming technique. So we will do the same thing. Okay, now we will do one thing. We will use, like as I told you, it is dividing this red box and this is dividing. So how we need to combine that, we will see. One simple is with the help of, like as I told you, comparing two string. Okay, that we will see now. So in the next page, what is the thing now? Comparing comparing to a string. In the previous uh, page, we saw to combine the two small Turing machine problem into one large Turing machine, okay, or comparing. So I will show you the comparing, then you can easily understand. A Turing machine to decide, so this is my the like W1 language, and I am using the hash between two programming or two strings, okay, and that W does not belongs to, sorry, W belongs to A comma B comma C star, A comma B comma C star, okay. So in this, what is this W? This W is first half, and this is second half. And what is this? This is a midpoint of the string. This is midpoint of the string. Midpoint of the string. So here I am using a new symbol, okay, for this. Sorry, I am using the new symbol. What is the new symbol? Is new symbol is X. I am using X. Take the example of X is a new symbol. So what is the use of this X? Replace each symbol into a X after it has been examined. After it has been examined, okay. So I am taking like example A B B A C hash A B B A C. So this is the two strings, and I want to compare is these both are equal or not, okay. So let's solve this in the new page. So what we are doing here, first we have taken the one new word, that is X, and now I am replacing each symbol into a X after it has been examined, after it is checking, okay. Then we will changing into X, okay. So what is the first, what was the example? A B B A C, this is a midpoint, and here also A B B A C. In the first point, what it will do first is it is changing to X, and rest of the string will be same. And here also it is changing to X, both are examined, and it's changed to X. This is the first step. In the second step, again this X is already there, the second one is also changing to X, and here rest So here the rest of the string will be same, and this hash and this x is already previous step we got that. So here this also it will get x, and rest of the string will be same. So in the same way, in the next step, again this 3 will be the x, and this 3 will be the x after examining, and this AC hash concatenate, and this last AC is there. Okay, in the same way, again in the next step, x, 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 and this also will x after examine this. Okay, and last is hash and concatenate with the hash, and the last one is C. And the last step of this is all are in X. Okay, what does it mean all are X? That means all are same. The comparison is 100% and this is same. What we can say here? It is compare both string are same. Both string are same. But what is the problem here? Like see, what is the first here? A, B, B, A, C. A, B, B, A, C. What is at the last? X, 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 X. And here also, but here we are losing the original string. Now we lost original string. This is good. It is compared and it is same. But what is the original string? We lost that. We don't have that. Okay. So this is a very important. We lost the original string. Okay. So here we lost the original string. This is very big disadvantage, and we raise the problem. Here the problem. Okay. So we need to solve this problem, and this problem we can solve with the help of non-destructly structure. Okay, without losing the original text, we can get it. How? That I will show you in the next page. Okay, so our problem is we are losing the original text. So here we can do, what is the solution for that is the small thing. We need to replace the original or unique symbol. Okay, we need each unique symbol. How many strings are there in your input? You need to use a unique string, unique symbol with another unique symbol insist of replacing all with the same symbol. What we were doing in the previously, we are using only a one symbol, and that is we are using for whole text. But now here what we are doing, we are taking the unique symbols for each with another unique symbol instead of replacing all with the same symbol. So previously we did the use the X symbol for all symbols. Okay, but now we can do give the symbol different symbol. Example, if I have a b b a c concatenation, or with the help of hash midpoint a b b a c, and here we are taking like how many new symbols are there? A, B, and C. The three are there. So here A, B, and C. Here we need to do one thing. So here what I will do, A, B, C. So I will change A with X, B with Y, and C with Z. Okay. A is wherever I have A in my input string, I will change to X. Wherever I will have B, I will change to Y. Wherever I have C, I will change to Z. Okay. So here the next is X, and this will also X. Sorry, yes, X. A is X. Then the rest of the things will be the same. Hash BBAC. Like this, it will go down. Okay, and at the last, we will get X. What is this? B. B replaced with Y, and this B replaced with Y, and A is replaced with X. C is replaced with Z. And here also X, B is replaced with Y, B is replaced with Y, A is replaced with X, C is replaced with Z. So this is about the comparison, and this is our the final answer. Okay, final answer. Here in the final answer, we got X, Y, Y, X, Z. So if you replace again, if you change, like if you change from X, Y, Z, okay, to original text, so what is the X? We already defined here is A, B, and C. So this is we got the original text. If you change this, then you will get the original text. Without losing the original text, we got the solution. So without losing the original text, we got the answer. So how we need to, like, this is a state, okay, and here we are getting the string, and it is doing the loop, and we are getting the final answer. Okay, so this is starting and we are getting the final. Again, whatever the final answer is there, if you do here, then it will be again and again it will do the same thing, and we will get the answer. If you want to restore the original text, so with the help of this you can restore. Okay, so this is about the without losing, we got the answer. Without losing the string, we can solve. So I am going to stop now here. In the next class, we are going to do the non-deterministic Turing machine. Okay, till now we have seen deterministic. Now we will see the non-deterministic in the coming classes. Okay, so thank you very much. This will be in the next class. So whatever we have done here, it is everything is available here. So make a note. Okay, make a note, then it will be easy for you, because this kind of notes you will not get online. So whatever you are learning here, whatever I am teaching you, just make a note of it, then it will be easy for you to memorize. Otherwise, again and again you need to come on the video and you need to watch. So if you write like this, okay, then it will be easy for you. This one we have creating the new when you are comparing, and this is ABBAC. This is a comparison, and the problem was, what the problem, we losing the original text. So for that we use the destructive algorithm or destructive technique, we can say, and with the help of this we change the unique symbol for a original symbol. So with the help of that we can restore if you want the original text. Okay, so this is about the thing. In the next class we will going to see the non-deterministic algorithm, sorry, non-deterministic Turing machine, and we will see and we will do some operation on it, and we will see the how it will work on tape and how to configure this, that all the things we will see. Okay, thank you very much. We'll see you in the next class.